another assignment of the course. So the main idea in this assignment is like we have to build something interesting, multi-step reasoning MCP tool, but also we have to evaluate the prompt based on the prompt standard given by the instructor. So I'm trying to build here is route optimization MCP agent. So this project is like automates a multi-city route calculation using a reasoning driven LLM agent. Here in this case, I'm using the Gemini Flash 2.0 as a LLM agent. The example scenario here is a round trip road journey. So we start from Seattle, um, and we go to the Portland, then again San Francisco, and back to Seattle. So it's a round trip, and the agent has to calculate the different things. It's a multi-city route calculation. So the agent connect to the MCP server, which is the route server.py, and I will explain the code later on. We have the tools like get distance, estimate fuel cost, and the verify round trip. And same as before, we provide those information to the Gemini. Say that we have these tools, you have to pass the params, and if you want to call those tools, just say that, and the agent will pass the Gemini output and call the server. And in the server we have the different formula, like I will explain the code here. So here in the server we have the we calculate the distance between the two cities using the RV sign in the kilometer, and we are multiplying by 1.2 because the road are not straight. It's just the approximate assumption to calculate the approximate distance between the cities. And the hard coordinates of those cities are hard coded here. It's just the approach coordinates, latitude and longitude, and we are using these to calculate the distance for the multi-trip, uh, multi-city round trip. So we have the get distance function. So we have the estimate fuel cost is also MCP tool, and verify round trip MCP tool, and so on. And we have another route agent, and this is the final prompt, final system prompt, which we have to evaluate based on the given standard. And this prompt is also written in final prompt.txt, the same prompt for the evaluation later on. So the agent also do the same, like it says like these are the tools available, you have to call those function, or just what you want to call, right? And we parse the output from the Gemini, we parse the tool, and we call the server, and the server has those function, and server return backs the output. And again we have the multi-step LLM reasoning over there for the round trip calculation. So yeah, that's the thing. And we have also another prompt evaluation.py. This is the file the instructor provided. Like we have to evaluate the um, prompt based on these criteria, and it has to return this JSON format, the LLM. And this prompt evaluation.py exactly does the same. We have the same final evaluation here, final evaluation instruction, and the final prompt is in final prompt.txt. So it asks the Gemini whether this prompt is based on this standard or not, and Gemini will give us the JSON output like true false exactly mentioned in this prompt evaluation criteria. So let's go for the demo. Here I'm running the Python route server here. It's already running. Let's try to run the this file, agent file. So Python route agent.py. So in the logs we can see processing request of type list tool request. So LLM gets the function call first. It tried to get the distance between the Seattle and Portland, and it called the tool. Again it called the tool, and we get the this JSON format from the server. And again function LLM called get distance from Portland to San Francisco. We get the response from server, again San Francisco, Seattle, and we get the response from server, and it calls like those fuels, calculate the fuels and those things, and we have the final output here. Seattle, Portland, total distance is this, fuel cost is this, and the verification forward kilometer, backward is this, delta percentage, and those things. This is just the log, and this log is also added in the readme file over here for the here the sample log. Let's try to evaluate this prompt, the this final final prompt over here by the criteria. So we have the file called so let's clear this out, and python prompt eval.py, let's run, and it basically asks the Gemini whether this prompt is good or not. Now we get the explicit reasoning is true, yes, structure output, tool separation, conversation loop, instructional farming, and so on. So the prompt is verified, and we also see the output of how the multi-step reasoning of the LLM works for round trip calculation. And also we have the code here, and the further explanation of the code is in appendix for more details. So yeah, that's it for this video.